In our previous video, we looked at imaginary numbers, and we mentioned briefly how they sort of fit into a larger set of numbers called complex. And these numbers, complex numbers, are kind of interesting, right? They're sort of something new, probably, and they're of the form a plus bi. So if you're in the complex set, you're probably in the form a plus bi. All right, where a is your real number. That's your real element. Excuse me. And this element right here is your imaginary component. So a complex number is basically a combination of a real number and an imaginary number, right? For example, this is a complex number. So is this. This is a complex number, and so is this, right? Sometimes your real term can be a 0, which is fine. Then you'll have something like this. That's a complex number. So is this, right? There's just a kind of a 0 here in front of it, right? So when you're writing these things, make sure you write the real term first and the imaginary term second. Now, in terms of how to graph these imaginary numbers, right, we're going to have a complex plane, which is a little different than the regular Cartesian plane you're used to. So if you're ever asked to graph, I'll put it in red here, if you're ever asked to graph the point, let's put it over here, let's say it's point A, and let's say that that point is 3 plus I. Well, the 3 is along the real axis, the x-axis, so that'll be your real axis, and the up and down axis, as you can see, has the imaginary, and together they form complex numbers. So 3 plus I is going to be right 3 and then up to I. So that's point A. Let's put another one. Let's put point B at negative 2 minus 3i. Well, that's minus 2 on the real, and then minus 3i on the imaginary, so it's down there. All right, I'll put one or two more here. Let's say we have negative 3 plus 2i, that's point C, so that's negative 3 this way, plus 2i is up this way. And let's see, one more, we'll put it in green color. Point D, let's say, is just, negative 3i. So it goes left and right 0, but just down, simply down to negative 3i, and there's point D. All right. Next thing we want to look at when we examine when we're introduced to a set of numbers is how to add, subtract, multiply, and divide those numbers. Example 1, let's add. So let's say we have 5 plus 3i plus negative 6 minus 10i. All you do here when you add or subtract complex numbers is you really just kind of want to look at the real components and combine those by addition. So that would be 5 plus negative 6. 5 plus negative 6 is negative 1. And you want to combine the imaginary components, 3i plus negative 10i. Well, that's pretty easy. That's negative, let's see, negative 7i. That's your answer. You can't really simplify anymore. A lot of times you won't see parentheses written around them, so it's just this. If you have subtraction, let's try this one. Let's try example 2. We'll subtract. And now we have, again, real to real, so negative 8 minus 10 is negative 18. imaginary to imaginary, negative 4i minus 2i. There you go. Example 3, let's multiply. So this was addition, so subtraction. Let's multiply now. So we have 6 plus 2i times negative 3 minus 5i. Alright, let's get some more space here. Well, here we're basically just going to distribute binomial into a binomial. That's kind of the thing that you probably learned in your math class, is to FOIL, right? So you're going to go first times first. First times first is negative 18. The outside times the outside is, let's see, let's highlight it, outside and outside. So we're going to multiply that, negative 30i. Inside times inside, negative 6i. And last times last is negative 10i squared. Alright, so that's, if you're following along here with your FOIL, if you learn it that way, F-O-I-L. We want to simplify. Negative 18, we'll combine those middle terms together. And we're also going to think back to our imaginary number definition, and we said something pretty interesting. We said that I squared is equal to negative 1. That was one of our definitions. I squared is negative 1. It's the only number that's like that. So negative 18 minus 36i minus 10 times negative 1. Simplify one more step. Well, two more steps. That's a plus 10. So this is actually negative 8 minus 36i. Notice that we can't combine real numbers and imaginary numbers by addition or subtraction. We can multiply them together like we did up here. You know, imaginary times real is, you know, just basically a combination of the two, negative 6i. Alright, and this is going to be our final answer right there. Let's try another one, number 4. Number 4 is going to be our division problem. So let's go ahead and take, we're actually going to do 2 of these, I think. Let's take, well, we'll do a different number here. Let's go 7 over 2 plus 8i. Alright, we'll do another example in a second. But for this, what you want to do is actually think about maybe a new word here. Think about what the heck this means, a conjugate. A conjugate is basically designed to, the goal of it is to eliminate the imaginary number in the denominator. And a conjugate is defined as, in this case, you keep the real number exactly as it is, and you change the sign of the imaginary component. We're going to multiply top and bottom by the conjugate of the denominator. So the conjugate of the denominator right down here is 2 minus 8i. And the goal of that is to get rid of the imaginary part in the denominator. Let's see if it worked. We're going to distribute 7 into this binomial, so it's 14 minus 56i. The bottom foils, so let's see what it looks like. We have first times first. If you want to put these in parentheses, it might help you. First times first. Outside is, let's see, 16i. Inside times inside is 16i. Last times last is negative 64i squared. The top can't be simplified anymore for right now. Down in the bottom, you'll notice that these cancel out. That was good. So it's 4 minus 64i squared. Keep going here. Minus 64 times negative 1. Remember, we said that there's a nice little substitution that can be made right here. I squared is equal to negative 1, so we'll make that substitution and simplify. 14 minus 56i, so it's 4. In the bottom it is 4 plus 64. So we have 14 minus 56i over 68. Okay? Those are all even numbers, so that's kind of interesting. We want to look at potential for simplification at any point here. These are all even numbers, 14, 56, and 68. So since they're all even numbers, let's cut them all down in half. 7 minus 28i over 34. And that is as simple as you're going to get it. All right, some teachers might, actually prefer that you split up the denominator. And if you do that, then this imaginary portion can actually simplify again. But for my class, I'm going to be okay with it staying in this format right here. Okay, one more here, number 5, another division. Let's divide binomial. -1 plus, we'll use a different number here, 9i divided by -10 plus I. So when you have a division, again, you're going to want to multiply by the conjugate, the complex conjugate. You're going to keep the real number the same. You're going to change the sign of the imaginary part. So the complex conjugate of -10 plus I is -10 minus I. All right, let me get rid of all this stuff over here. So we have, let's see, FOIL on the top. We're going to go 10. Outside is plus I. Inside is minus 90I. Last is -9I squared. Make sure I didn't screw up there. I think I'm all right. -9. Yeah, that's good. In the bottom, first times first. Outside times outside is positive 10i. Inside times inside is negative 10i. Those will cancel. -I squared is the last times the last. Simplify further. 10 minus 89i plus 9. Remember, this I squared becomes -1, so it's -9 times -1. And the bottom we have, let's see, 100. Cool part about this, the whole point of conjugates is to eliminate the imaginary part. It did disappear. And -I squared, that's -1 times -1. It's kind of confusing, I guess. It's just minus -1. All right. Again, simplify 10 plus 9 in the numerator is 19 minus 89i over 101. And that can't simplify anymore, so we're going to leave it like that. Again, some teachers might require you to write it as the difference of two separate fractions, which is the same thing. Alright, so those are the basic arithmetic operations on complex numbers. Pretty soon we're going to learn that a lot of quadratics have complex roots, and we'll learn how to calculate those roots using quadratic formula.